Hello everyone, welcome to Mr. Schultz's class. Please write your information in the top left-hand right corners, and let's begin our notes on functions. Functions are mathematical machines. For every input, there's exactly one output. Now you might think sometimes that the machine is broken, but think about this definition while we go over some of these examples. So example 0, the soda machine. If you push a Coke button, and out pops a Coke. You should think every time you push that Coke button, you get a what? Now, this machine isn't broken. You understand, you push a Coke, you get a Coke. Now, if you push the Coke button, but out pops a root beer, now, you might think, it's broken. But the machine is telling you, if you push this Coke button, you know what's going to happen. Out is going to pop out a root beer. So if you keep pushing the Coke button thinking something else is going to pop out, then, nah man, out will pop out a root beer every single time. Because the rule is, you push the Coke button, you get a root beer. Now sometimes you'll have a machine that you might think is broken. You push a button, you get a Pepsi. You push the root beer button, you get the Pepsi again. You push the Pepsi, you get the Pepsi. You push the Dasani water, you still got the Pepsi. In this case, there are multiple inputs that will give you the same output. Now, just because you don't like the output doesn't mean that it's not a working machine. The only time this would be broken is in the following scenario. You push the Coke button, you get a Coke. You push it again, you get a root beer. Now all of a sudden, the input of pushing a Coke button gives you two outputs. You get a Coke or root beer. This is not a function. This machine is broken. It ain't a function anymore. Let's go on. So we can identify functions, and we can determine whether each of these functions, these relations, are a function. Just know this vocabulary or this definition. Every input, so let's write this down. Every input only has one output. So every input only has one output. Well, let's see. This -4, let's look at it. -4 goes to a -1, that's only one. -2 to 3, -2 input only has an output of 3. A 2 has an output of 3, and a 5 has an output of 6. Now, although that there's multiple outputs with the same value for different inputs, every input only has one output. So this is a function. Because every input only has one output. So let's look at B. The 2 goes to 3, the 6, 5, 8, 5, 2, -3. Now some people might go, hey, look, they share 2 5s. Well, we don't care about that. Remember the Coke? You push Coke, you got a cherry Coke. You put Dasani, you got a cherry Coke. The machine's not broken. Every button gave you a cherry Coke. In this scenario, you have the input of 2, and you pushed it twice. This has 2 outputs. If you push a 2, you could either get a -3 or a 3. This is a mapping of it. You get 2 choices. And so this is not a function. So this is not a function because the input of 2 has 2 outputs, -3 and 3. There we go. Let's look at the last one. 2, 5, 4, 7, 8, 11, 4, 13. Now once again, we look at the inputs. Do any inputs repeat? Now the 4 does. So if we look at this, we see that 4 has an output of 7 or 13. So once again, this is not a function. This, look at that here. This is not a function because the input of 4 has two outputs, 7 and 13. It's just you can only have one output. For every input, there is only one output. Let's go on. All right, guys. So it says, example 2 and 3, analyze data and equations. So anytime they give you data, you could make a table. And so if you made a table, you put it from least to greatest. So 0, 1, 1, 2. And therefore, if you write it down, you should be able to tell right away, hey, look, they're the same. Or if one was not the same, you're like, oh, look, two outputs, not a function. So, we can read this data easier and describe the domain and the range, and whether the relation is a function. The domain is going to be the x values from least to greatest. The range is going to be the y values from least to greatest. Now, this can sometimes be a problem when we have a graph such as this, because they're not increasing at the same. Once the x values are increasing while the y values are decreasing, so it can be a little tough. So just understand that we can analyze data if we put it in order that is easier for us to understand. Let's go on. Example 4 and 5. Find the function values and evaluate the functions. So if f of x is equal to negative 2x plus 9, this is pretty much saying right here, hey, I want you to input 4. So normally our input is going to be x. So they want us to input 4 and then get the answer right here. I don't know what the answer is. I'm going to put a big old circle right there. And then they want to say, hey, add 3 afterwards. Fine, I'll do that. So f of x is equal to negative 2, and then we have this 4 right here. We're substituting 4. And then we have plus 9. And so now we're going to add 3 now. Fine, I can do that. So negative 2 times 4 is negative 8 plus 9. And then we still have this plus 3 right there. So negative 8 plus 9 is 1. We still have that 3. And so, f of 4 plus 3 would equal 4. That's it. So sometimes we're going to be asked to add certain things or subtract certain things with functions. All right, next up. It says, hey, what if I have f of 5? I input 5, and then I subtract f of 1. Okay, well, we have to figure out what f of 5 is, and we have to figure out f of 1. Now, we could just, make our function and just be like, all right, so we have negative 2 times the quantity 5 plus 9, and then we're going to subtract negative 2 times 1 plus 9. All right, well, let's solve this. Negative 2 times 5 is negative 10 plus 9. And so we have this grouping right here where we're going to have to figure out negative 2 times 1 is negative 2 plus 9. So we still have to figure out each one of these. So negative 10 plus 9 is negative 1. We still have this minus sign. And then negative 2 plus 9 is 7. Well, now he can break out. So it's negative 1 minus 7. Well, that would be negative 8. So f of 5, if we input 5, what's the output? And then we subtract by the input or the output of when our input is 1, that would be negative 8. Now we could have just figured out, hey, what is the output if we plugged in 5? Get that answer, which would have been negative 1. So we would have had something like this. We had like -1, so 5 would be -1, and then 1 would be, what was it, 7? And then it says, hey, subtract them. So -1 minus 7 would be -8. There's multiple ways for you to figure this out. All right, last example for today. I dislike going over 10 minutes, but here we go. So interpret function values. Mason works at the movie theater after school. The function g of x is equal to 9.25 times x. Represents the amount of money he makes before taxes each hour that he works. Evaluate and interpret the function for each value. Okay, well, g of 8. That means we're going to plug in 8. So that's equal to 9.25 times 8. So if I was going to multiply this, I would do this. I'd be 9 times 8 and 9 times a quarter. So this is a quarter. A quarter of 4 is 1. A quarter of 8 is 2. So 8 times a quarter is 2. Now 8 times 9 is 72. Now I can add these together and get 74. So g of 8 is equal to 74. What does this mean? Well, using our handy dandy information, we can say, hey, Mason is working 8 hours in order to make $74. That's it. Let's go on to the next one. Now at the moment, I can already say, hey, the dependent value is 14. Mason has worked 14 hours. Well, what did we get? Well, this is equal to 9.25 times 14. So 9 times 14, that would be 99 plus, so I know there's going to be 11 and 3. I'm trying my best not to get a calculator out. I don't want to do that. So 9 times 14 would be 99 and then 27. Add these together, 126. So I know 14 times 9 is 126. Now I'm figuring out what is 0.25. So I know that that's a quarter times 14. Looks like I'm going to have to use a calculator. So give me a second. Alright, I was trying my best not to use it. So if I actually do 9.25 times 14, I would have probably gotten 129.5 is equal to g of 14. What does this mean? Well, going back over here, I know he worked 14 hours. He earned $129.50 for working that much, I guess. Thank you, and I'll catch you later. See you in class. Have a good one.